Welcome back in the lecture of refrigeration and air conditioning. Today we will be discussed about cooling load analysis. So what is load analysis? So before any air conditioning system can be installed for either summer or winter, the cooling load and heating demands on this system must be established. This is known as the load analysis. Now classifications of cooling load analysis. There are classified in three category or three types. First is according to the season, summer cooling load and winter heating load. In summer cooling load, it is the amount of heat which must be removed per hour to produce and maintain the design condition within the space. Now in case of winter heating load, it is the amount of heat which must be supplied per hour in order to obtain the same result. Now second is according to the types of load. First is sensible heat load and second is latent heat load. Now in case of the sensible heat load, any heat source that rises the dBT means drivable temperature of the air in the conditioned space causes a sensible heat gain. Now in case of latent heat load, any source that adds the water vapor into the air in the conditioned space causes a latent heat gain. Now third and last is according to the positions of the load. First is external loads and second is internal loads. Now in external load, any load that are coming from the space which is not air condition is outdoor load, or you can say that external load. Now in case of an internal load, any load that are produced within the conditioned space, it is indoor loads. Now next is effect of flywheel on the building material, or you can say that flywheel effect of building material. As we all know the working of the flywheel, just as a engine, flywheel stores the rotational energy and release it when torque is at minimum to smooth out the performance of a engine. So does the mass of building store the heat during the hot part of the day and release it later on. The storage depends on first is mass of the building material and second is specific heat of the building material. So the building material will be in position to absorb the heat gain after release. So this heat inertia of the building material is known as a flywheel effect or storage effect. Now as shown in the figure, a typical solar heat gain for a west side wall, the two curves are of IHG and ICL. IHG means instantaneous heat gain and ICL means instantaneous cooling load. Both the curves are not identical. The heat which is striking the surface is not directly transferred to the conditioned space, and therefore there is a no ICL means instantaneous cooling load. So from the figure it is clear that there is a reduction in load as you can see here, and there is a time lag in the peak load due to storage effect of the building material. So the figure also shows the pull down load. The heat which is being stored and released till the equipment start working again will be an additional load on the equipment. So this is known as a pull down load. The air conditioning equipment, therefore, the air conditioning equipment are started around 1 to 2 hours earlier. For example, For example, you can take cinemas or theaters. Now, next is use of flywheel effect in design consideration or use of storage effect. So, as discussed in the previous article or theory, every structure are capable of absorbing and retaining heat striking on it. So, it can take comparatively long time for heat to penetrate, means inside of the surface of the wall and roof. So, as discussed earlier, in order to remove the pull down load, the equipment is started earlier, means air conditioning system started earlier around 1 to 2 hours. So, full capacity of equipment will be used to remove the pull down load, since at that time other loads are not present. Also, the temperature of walls and roof will reduce further, and they are capable of absorbing more heat when load increases again. So, this will be effectively used in reducing the capacity of plant in small commercial and residential installation, which is shown in this figure. Thank you. Hope you understand all.